This video is all about a gas pipeline flows at 110 million standard cubic feet per day of gas at specific gravity of 0.65 and viscosity of 0.00008 pounds per feet seconds. Calculate using the modified Colebrook-White equation the friction factor and the transmission factor. Assuming MPS is 20 pipeline, 0.375 inches wall thickness and internal roughness 700 micro-inch. The base temperature and base pressures are 60°F and 14.7 psi respectively. Now, all we're asked to calculate is the friction factor and the transmission factor using modified Colebrook-White equation. So now let's begin. Now for us to solve for this, we need to calculate the Reynolds number. Now to calculate the Reynolds number, the formula for the Reynolds number for this empirical units, what you use is 0.00047778 times base pressure divided by base temperature times bracket open gas gravity times the flow divided by viscosity divided by the internal diameter. So now this is what we use. So where R is the Reynolds number, dimensionless. Now you have this as the base pressure. Now we have this as the base temperature. And then we have G as the specific gas gravity. Now we have Q as. So now the basic pressure is in PSI. The basic temperature is in Rankine. Now this is dimensionless. Then the flow rate. This is the flow rate of the gas in the pipeline. Now this is in standard cubic feet per day. So for us to solve for this now, so we have the Reynolds number equal to 0.00047778 times base pressure divided by base temperature times gas gravity times flow rate divided by viscosity divided by internal diameter. Now internal diameter is equal to the outer diameter minus 2 times T. Now the outer diameter is 20 inches minus 2 times the wall thickness. Now but before we use these values, let's write down the informations. Now the outer diameter of the pipeline is 20 inches. The wall thickness is 0.37. inches. The base pressure is 14.7 psi. The base temperature is 60 degrees Fahrenheit, which is equal to 460 plus 60. In Rankine, which should give us 520 degree Rankine. So we have the base temperature will be 520 degree Rankine. Now we have gas gravity to 0.65. We have the flow rate to be 110 times 10 raised to the 6 standard cubic feet per day. Then we also have the viscosity to be 0.000008 pounds per feet seconds. We also have now the internal diameter of the pipe to be the outer diameter minus 2 times the wall thickness. So we have 20 minus 2 times 0.375. Now that means D will now be 2 times 0.375 will give you 0.75. So we'll give you 3.75. So now minus 0.75 from this 20, you have 19.25. So that means the internal diameter will be 19.25 inches. Now, so that is what we're going to use to calculate our Reynolds number. So our Reynolds number will now be equal to 0.004778 times the base pressure is 14.7 divided by the base temperature, which is 520, times the gas gravity 0.65 times the flow rate, which is 110 times 10 raised plus 6 divided by 0.00008 divided by 19.25. Now let's make use of our calculator. We have 0.65 0.65 times 110 exponential 6 divided by 0.00008 divided by 19.25 divided by 520 times 14.7 times 0.0004778 equal to, we have 6,271,125. 6,271,125. That is our Reynolds number. So since the Reynolds number is greater than 4,000, so it is a turbulence flow. So we are going to use modified Colebrook-White equation. So we're going to use modified Colebrook-White equation. So now we have our Reynolds number to be equal to 271,125, and the roughness is 700 times 10 raised to power minus 6 inches. Now we have our D to be 19.25 inches. So now let's use the modified Colebrook's equation. So 1 over square root of f is equal to minus log to base 10 bracket open e divided by 3.70 plus 2.825 divided by not the number square root divided by square root of f. That is This is a modified Colebrook-White equation. Now this is 2, sorry here. So for us to solve for friction factor, let's assume the friction factor is equal to 0.01. So now let's substitute value of f to be equal to 0.01. Now we're not going to substitute, we'll substitute this value for the information for the expression on the right hand side. But for the expression on the left hand side, we use the value we get on the right hand side to calculate for the value on the left hand side. So what I'm doing in essence is that since this is an implicit function, we're going to use an iteration method to solve for f. So we now say 1 over the square root of f is equal to minus 2 log e is 700 times 10 raised to 4 minus 6 divided by 3.7 times 10 times 19.25 plus 2.825 divided by the unknown number, which is 6271,125 times the square root of 0.01 to base 10. So let's make use of our calculator here. So with this calculator, let's solve for the information on the left hand side, on the right hand side. So we have 700 exponential 6 minus 6 divided by 3.7 divided by 19.25 plus 2.825 divided by 6271,125 divided by 0.01 raised to 0.5. So we have this. Now we'll do log of this. So now we'll just place this log. We have minus 4.8. So now multiply by 2 minus 2. So we have 9. So what we have here is 9.687. 9.687. So So what we'll get now is this will be equal to 9.6873. So it means 1 all over the square root of f is equal to 9.6873. So now on both sides, take the inverse of both sides. The inverse of 1 all over square root of f will give you square root of f. The inverse of 9.6873 will give you 1 all over 9.68773. Now, to get our f, you square both sides. You square both sides. You square both sides, you have your f. It implies that f is equal to 1 over 9.6873 all squared. So what is our f now? So what we get, let's now make use of our calculator. So the inverse of this, we click the inverse button, we have 0.103. So the inverse of this square, so what we have now is 0.01065559. Let's see, 0.01065559. So this is the value of our f. So now, since the value of f is much, it has a much difference between the assumed value which we use as, we assumed as 0.01. So since there is a lot of variation, now we continue with our assumption. Now in this case, we are going to now make use of this as our assumed value. So we're now going to assume f to be equal to 0.0161065559. So if having assumed value, so now we're going to input it into the right hand side of this equation. 1 all over the square root of s equal to -2 log e divided by 3.7 d plus 2.875 divided by real number divided by the square root of f to the extent. So I will now say minus log 700 times 10 raised to the -6 divided by 3.7 times 19.25 plus 2.875 divided by, sorry, not 7525, sorry, 25 divided by the real number, which is 6271125 divided by the square root of the assumed value of f, which is 0.106559. This thing. So let's use our calculator now to solve for this. Now invoking our calculator, we now have 700 exponential 6 minus 6 divided by 3.7 divided by 19.25 plus 2.85 divided by 6271125 divided by 0.0010601065595 raised to power 0.5 by something that is square root equal to this. Now press log 10, log to base 10, have minus 4.84. Now say times minus 2, have 9.6959. So if you take the inverse of both sides of the equation, just as what we did here, take the inverse, you have the square root of f equal to 1 all over this value. Then when I say squaring both sides, we now have our f. So squaring both sides. Now let me take the inverse first. The inverse is this. Squaring both sides, we have 0.010637 63708 is what I will do. So that means our f is equal to 0.01063708. So since this value will be different from here, now let's do the next iteration. So what we're going to now assume f to be equal to 0.01063708. Let's look at our calculator to see if what we wrote is correct. Is okay, correct. So I will assume this value. Now we're going to impute it into the right hand side of the equation of the modified Colebrook-White equation. So now we're going to say 1 all over the square root of f is equal to minus 2 log e bracket open e divided by 3.7 divided by b plus 2.85 divided by Reynolds number divided by the square root of f to base 10. So now we now have minus 2 log 700 times 10 raised to the power minus 6 divided by 2.7 divided by 19.25 plus 2.825 divided by Reynolds number, which is 671,125 divided by 0.01063708. Now let's use our calculator to find f. So to find f, we now have 700 exponential minus 6 divided by 3.7 divided by 19.25 plus 2.825 divided by 6271125 divided by 0.01063708 raised to 0.5 equal to log this times 2 minus 2 equal to 9.69568. So we now take the inverse of this, square it. We now have 63759. So what we have now as our value is 0.063759. Now, if you look at these values critically, here is 8, here is 7. Sorry, here this is 0, 1. Sorry. So from here to here is almost the same. So that means we can now say our final answer. We can approximately say our final answer is 0.0106. This is the final answer into 4 decimal place. That's the final answer. So let's now look for the transmission factor, which is 2 all over the square root of f. So this will give us 2 divided by the square root of 0.01106. So let's calculate this. Let's use our calculator. Calculate this value now. We have 2 divided by 0.0106 raised to power 0.5 equal to 19.43. So we have 19.43 as the transmission factor. Now the friction factor is this, why the transmission factor is 19.43. So this is our final answer. Thank you for watching to the end. Have a nice day. Also do well to subscribe and hit the notification bell so anytime I make new video you'll be the first to watch it. Thank you and God bless.